Okay, measures of center and spread. These are ways of looking at data and analyzing what's going on with data. So first, the measures of center. What do the measures of center do? They point to the center of data. What we're looking for when we're looking at measures of center is we're looking for a value, a number that represents the entire set of data. Okay? The two measures of center that we're going to look at are the mean and the median. So the mean is represented by this symbol. It's the variable x with a line over it. And the mean is the sum of all values in a set of data divided by the number of values in the set of data. So we would add all these numbers together and then divide by the number of numbers. And what the mean gives you is a number that represents the set of data. For example, your grade on the report card is a mean. It's an average. If you get a B on the report card, that does not necessarily mean that you got a B on every single assignment you did for that class. What it means is that B is the grade that best represents how you did as a whole. You may have had some A's, some C's, some F's, but B represents best how you did as a whole in that class. So that is a good example of mean. Another measure of center is the median, and the median is the middle number in the set of data, but it's important to recognize that it needs to be an ordered set of data, which means you need to put the numbers in order from least to greatest, and then you find the middle. Now, the measures of spread don't look at the center, obviously. What they're looking at is all the numbers, and they're looking at how those numbers are distributed, how those numbers are spread out to analyze that. The first measure of spread we're going to talk about is called range, which is the difference between the greatest and least values in a set of data. And there's also the interquartile range, which is similar to the range, but we're not looking at the greatest and the least values. We're looking at these values that are called the upper and lower quartiles, or sometimes called the third and first quartiles. And we're looking at the difference between those. And I'll show you how to find that. So let's go ahead and take a look at these two examples here and work them out to find our data points. Okay, so let's first take this set of data here, 15, 23, 25, 10, 18, and 23, and find the mean. So first we're going to add these six numbers together. And when I add 15 plus 23 plus 25 plus 10 plus 18 plus 23, I get 114. Okay? And there's six numbers. When I do 114 divided by 6, I'm going to get 19. And that's my mean for this set of data. My mean is 19. Let me write that here. My mean is 19, okay? Now, in order to find the median and the rest of this, what I want to do first is I want to go ahead and put these numbers in order from least to greatest. So our first number here is going to be 10, followed by 15, and then 18. Then we got two 23s. And we've got 25. Okay? So now, the middle of this set of numbers is actually right here in between 18 and 23. So then what number is right in between 18 and 23? Well, an easy way to figure that out would be to add these two numbers together and divide by 2. So if I say, okay, 18 plus 23 divided by 2, well, 18 plus 23 is 41, and 41 divided by 2 is 20.5. So my median for this set of data is 20.5. Okay? And another thing that I can easily find here is the range. The range is the difference between the greatest and the least values in the set of data. So my greatest value in this set of data is 25. And my least value in this set of data is 10. Let me write that this is the median. Okay, so my range is going to be 25 minus 10, which is 15. So the range for this set of data is 15. So now how do we find the interquartile range? Well, in order to do that, we need to divide this set of data into 4 equal parts, into quartiles. we've already started the process by finding the median. What happens when you find the median is you actually divide your numbers in half. You divide your set of data in half. So this here is the lower half from 10 to 18, and this here is the upper half from 23 to 25. And so to find the first quartile and the third quartile, we just need to find the median of each half. So the median of this lower half is 15. We call that the first quartile. That is Q1. And then so I go now to this upper half and I find the median of this upper half is 23, and we call that quartile 3, Q3. And you can see that we divided these numbers into 4 equal groups. You see here 1, 2, remember this is the median, is divided in half, 3, 4. And so the interquartile range, the IQR, is the difference between Q3 and Q1. So here we have 23 minus 15 equals 8. So my interquartile range is 8. All right, hopefully you understood that. Let's go ahead and take a look at this next set of numbers. Let's find for 4, 5, 7, 13, 4, 7, 12, 16. Let's go ahead and find the mean. So we're going to add these numbers together. So 4 plus 5 plus 7 plus 13 plus 4 plus 7 plus 12 plus 16 is 68. And 68 divided by 8, because there's 8 numbers in this set, equals 8.5. And that's our mean for this set of data, 8.5. Let me try to do this one a little more organized. So now our median, or in order to find our median, we need to put these numbers in order from least to greatest. So we have 2 4s, we have a 5, we have 2 7s, we have a 12, we have a 13, and we have a 16. Now let's go ahead and find everything right off the top, okay? So let's find our median. There are 1, 2, 3, 4, 5, 6, 7, 8 numbers in this set. So our median is going to be in between these 2 7s. So what number is in between 7 and 7? Well, that would be 7. So that's my median there. My median for the set of data is 7. It's not 7. Yeah, it is 7. All right, sorry. I got confused for a second. No problem. Now, what do we have here? Well, we have, like we showed before, we have here our lower half and our upper half. So we got 4, 4, 5, 7 in our lower half. And so what is our Q1 is going to be in between 4 and 5. And that is 4.5 is our Q1. And our Q3 is going to be in between 12 and 13. And that's 12.5. And that's our Q3. So now we can do the range, which is 16 minus 4. And 16 minus 4 is 12. And we can do the interquartile range, which is going to be 12.5 minus 4.5, which is 8. Okay, so the third measure of spread is called standard deviation. And standard deviation looks at how each number in a set of data is spread away from the mean. And it's not difficult to do, it's just a few steps. It's like 5 steps to find the standard deviation for a set of data. None of the steps are difficult, it's just 5 steps. So let's go ahead and take a look at those steps. The first step is we have to find the mean for the set of data. Okay, So that means we have to add these 6 numbers together, 21 plus 31 plus 26 plus 24 plus 28 plus 26, and divide by 6. So we should end up, if we do this correctly, 156 divided by 6, and that equals 26. So the mean for this set of data is 26. So now what we're going to do with that is we're going to go into this table here that's already been set up for us, and we need to find our deviation from the mean. And you see here it says x minus x with a line over it. Remember, I've told you x with a line over it is a symbol for mean. And x is each number here. So all you're doing is subtracting each number in the set of data minus the mean. So for example, here, our first number is 21. We're doing 21 minus 26, and that equals negative 5. Then next is 24, so 24 minus 26, that equals negative 2. 26 minus 26 is 0, so we know this one's going to be 0 also. 28 minus 26 is 2, and 31 minus 26 is 5. So now after we've done that, we're going to come here and we're going to find the squared deviation. Now if you look here in this parentheses, you notice it's the same thing that's written here, x minus the mean. So here now in parentheses, x minus the mean squared. So what does that mean? It means take your answers from this column and square them. Multiply them by themselves. So what's negative 5 squared? Well, that equals positive 25. You know what else equals positive 25? 5 squared equals positive 25. Okay, so here we have negative 2 squared, and that equals 4. And 2 squared also equals 4. And obviously 0 squared equals 0. So now we have a new set of numbers here called the squared deviations. And what we're going to do now with those numbers is we're going to find the mean for these squared deviations. That means we're going to add these together and divide by 6 again. So we're going to say, well, all right, 25 plus 4 plus 0 plus 0 plus 4 plus 25 divided by 6. Okay, and that gives us 58 divided by 6, and 58 divided by 6 gives me 9.6 repeating. So we'll call it 9.67. And that is our mean of the squared deviations. So we got the mean for the set of data. We subtracted each number minus the mean. We took those values and we squared them. And then we took these new squared deviations and we found the mean for them. And we have one last step to find the standard deviation. And that is we want to find the square root of 9.67. Okay, so on your calculator, depending on which calculator you have, the way you find square root might be to punch in the number 9.67 and then hit the square root key and it'll give you the answer. Or you might have to punch in the key for the square root or the radical key, then punch in the number, then hit the equal sign. But one of those two methods should give you the square root. But so when I get the square root of 9.67, it's going to give me an irrational number. When I round it to the nearest tenth, we should get 3.1. So the standard deviation for this set of data is 3.1. All right, let's do one more example, this time without a table. We'll have to make the table ourselves. No big deal, right? So we see our set of data here is 17, 25, 20, 10, and 13. So first thing we want to do is we want to find the mean. So we're going to add these numbers together. 17 plus 25 plus 20 plus 10 plus 13, that is 85. And there's 5 numbers, so we're going to divide by 5. And 85 divided by 5 is 17. So that's our mean. Our mean is 17. Okay? And now what we need to do is find the deviations from the mean. So we have to subtract each of these x values minus the mean. So let's go ahead and make a table here with our x values. So this is going to be our x values, and let's put them in order. So 10, 13, 17, 20, and 25. And then here, remember, we're going to do x minus the mean. All right? That was an ugly line. Try that again. Much better. All right. So here we have 10 minus 17, which is negative 7. Here we have 13 minus 17, which is negative 4. 17 minus 17 is 0. 20 minus 17 is 3. And 25 minus 17 is 8. All right, so our next step is going to be to get the squared deviation. So we're going to take our answer from this and square them. So negative 7 squared is 49. Negative 4 squared is 16. 0 squared is 0. 3 squared is 9. And 8 squared is 64. Once we've done that, now we want to get the mean again for these new numbers. So we're going to add together, okay, 49 plus 16 plus 9 plus 64. That should give us 138. And divide by 5 again, because there are 5 numbers. And that gives us the number 27.6. So that's our mean of the squared deviations. And in order to get to our standard deviation, we need to find the square root of 27.6. We're going to round that to the nearest tenth. So our square root of 27.6 rounded to the nearest tenth is going to be 5.3. All right. Hopefully this helps you to understand the measures of center and spread, especially standard deviation.